So let's talk about two things today, translations and reflections. Now, before we do that, let me give you an overview of transformations. What is a transformation? Well, it could be like an equation that you move. So maybe, I don't know if you did this last year, but maybe it's like a parabola that then you change where it's at, or dilate or something. So you might have done that last year. If not, you'll do it next year. For geometry, we'll take shapes, or it could just be a single point. But usually it'll be like a shape, like a triangle. And we'll transform it according to these four. A slide, which we call a translation. Left, right, up, down, diagonally. We flip something, we'll call it a reflection. A rotation, which is turning a figure. And a dilation, which is enlarging a figure or shrinking a figure. So again, it could be an equation, or it could be a different figure. It doesn't have to be a triangle, but normally what we're going to do is a point, a triangle, or like a quadrilateral. There's some good applications of this, computer graphics and design, some art when you have to repeat and rotate. You want to draw a similar shape on the other side, you have to reflect it. Tessellations, we'll talk about that later, but a repeated pattern.
Like the thing with the triangle inside the triangle inside the triangle inside the triangle inside. What?
That's not a pure tessellation, that's just like a pattern. I forget what that's. No, I think, weren't you the one I was showing you a picture? Tesla, you can flip it over on the back page as a tessellation. At the top. Weren't you the one who asked about that?
No, I don't think so.
Is this what you're talking about?
Yes,
now?
that's what I'm talking about.
Yeah, that's something a little different based on Pascal's triangle. So, that's what I thought you were. I was like, similar at least, right? It might not be exactly this, but triangle, and then even that one you can keep breaking up. Well, anyways, so yeah, tessellation is a little different, but let's talk about translations first. This one, the figure changes position, but it does not change shape or size. So you're sliding it left, right, up, down. That's pretty much all we'll do. Now we might do up and right, so that kind of diagonally overall. Now this is for any transformation. This is important. The original figure is called the pre-image. The new transformed figure is called the image. Pre-image and image. Oh. Well, now what? Well, that's another option they could have done. Here's the, yeah, or pre-image and post-image. How about that? Now there's one pre-image, which you start with, and image is the result. Now, what was I going to say? Oh, on a graph, they're going to indicate the new figure, the transformed figure, the image, with these little apostrophes. That is pronounced A prime, apostrophe. So this was the original triangle, this diagram. The new one is A prime, B prime, C prime. There's no reason that that's dotted. You don't normally have to do the new figure dotted. It's just this one it was. Let's see, so they use the primes, A prime, B prime, so it would be triangle, A prime, B prime, C prime. This is a translation. Now, here's for a translation. You can just choose one point if you know it's a translation. It moved left 5 and up 2. And if I did every other one, it would also be left 5 and up 2. Yeah, that's a translation. Move every single point the same distance left, same distance up. Okay, now this might be new. Last year now the test could also just say, in words, move it left 5 up 2. Or they're going to write a rule. The rule is right here. You start with this. This is for any transformation, x, y. So that would say 1 point on your pre-image. The arrow means you're going to transform it. And then in your new parentheses, you write the new transformed rule. So the rule that you're doing. Just like with slope-intercept forms, like you have an x and a y in there. So I'm still going to have an x and a y. And then you're doing some type of rule to all of your points. So on translation, this one's pretty easy. You just say, all right, well, I'm going left 5. Left is negative on the graph. And so it's going to be x, and you put a minus 5. What's in every point you go left 5? X coordinate. And then the y's we went up 2, so that's plus 2. Overlaps a little. Now, you can just remember that this is left 5 up 2, that's the rule. If you're trying to plot a point, so my original, if you knew that was the rule, and C is 4, negative 1. If you want the new point, you could plug in x being 4 and y being negative 1. So really what these rules say is any point, plug in the original x and y coordinates, plug in that original point, into this rule, and that will give you the result. So 4 minus 5 is negative 1, negative 1 plus 2 is 1, and yep, that did do it correctly, plotting that point. Okay, so I'm saying translations, yes, it's probably just going to be easier to count. But it's also, I'm just saying this rule is being able to follow that is important too. Let's see, anything else I can clarify on that? Now, I'm going to come back to this true or false in a second. I had these backwards. So it is important, they want you to know this. If the pre-image and image of any transformation are congruent, if they're congruent, the transformation is called a rigid motion. So I've also seen it sometimes classified as a congruence transformation. I think rigid motion is one that they're going to say more. I think this one's actually probably a little better because it says it in the word congruence transformation. It's transforming something and it will be congruent. But they like using this word. Rigid means its properties are not changing. It's rigid, it's firm, it's not changing. It's changing where it's going, but the properties remain the same. So rigid motion, it just means your new shape is congruent to the original. So we're going to answer this one up. So I want you to do this. On your paper, circle true or false. Any translation is a rigid motion. So circle true or false. Take about 15 seconds. Think it over. Circle one of the two. Let's see, so what'd you go with? How about, let's do it here. How about Sarah?
I said false. Am I wrong?
Well, perhaps.
Well, then is it true?
Yeah. Yeah.
Second guess.
Well, rigid motion means the pre-imaging and image are congruent. And if you're any translation, you're taking a figure and sliding it, the new image will still be the same triangle or same quadrilateral. All the lengths will be the same, the angles will be the same. It's still congruent. Okay, if you're just sliding it. All right, well, good try. So this one, yes, I'm not going to answer this one. In the above example, yes, it's a rigid motion. It's a translation. All right, let's do two, one graphical and one getting the rule. So first one, graph and label the figure and then apply this transformation. So let's graph this quadrilateral. We've got 4 points. So there's W. 7, 3. That's X. -2 is Z, and then 3, -2 is Y.
Wait, do you have to write that to do those points and the transformation?
This is the original. So here's the given figure, and then we're going to apply this transformation of that rule to this. Does that answer your question? That's allowed. I didn't hear it. I didn't. WXCY. Apply the transformation to the pre-image. So there's it. This is the pre-image. So this rule, once you now, I should be more clear on this one. They could ask you to graph it or list the coordinates. So you could list all the 4 points, the new ones, or graph it. Why don't we just graph this one? So go ahead and do it. I want you to try it based on that rule. graph the 4 new points. Just to make sure you're on the right track, you should say this is right 1, x plus 1, and then the y minus 3 is down 3. So each point, right 1, down 3. So there's the result, every point, right 1, down 3. If they said list the coordinates, I would just graph them first, and then, list them. For example, w prime is 3, negative 2. Okay, and then you could list all the others. Okay, but they'll always say graph or list. Oh, also, if they said just list the coordinates, and we could have done this as well, but you could use the rule. So I could actually plug 2 in for x and 1 in for y into the rule. And 2 plus 1 is 3, and 1 minus 3 is negative 2. So the rule, right, is for each point. So you can use the rule as well. Basically, everything we're doing in this unit, there's a graphical approach, like counting and stuff, like I did there, or there's a formula for it. It's kind of nice, 2 ways. If you're more of a formula person, you can do the formula. If you're more of a visual person, do the grid. Number 2, write the rule from the diagram. Hopefully you noticed on this one that this is the pre-image. This is where we start. Did you catch that? This one has the primes on it. Some students just immediately say, oh, well, left to right. Well, no, I started with this one. You should eyeball it. It does appear to be, it's not reflected. It's not purely, rotation would be a different orientation down here. It's not changing size. So they did just translate it. They slid it. So the rule is going to be, here's how we write it, x, y, arrow. And then I'm just going to look at one point. I'll just do A. I'm just going to count on that one. Looks like 8 and 7. And so I'm going to write that x's first is left 8, so x minus 8. Down 7, so it's y minus 7. You can verify if you'd like, but all the others like B, C, and D also go left 8, down 7. Yes, it was a rigid motion. It did not change size or shape. All of the translations are. Okay. We'll talk about reflections now. Anything I can review though on translations? Yeah, so flip it over. Let's talk about reflections a little bit here. So reflection is flipping a figure over what we call a line of reflection. Right, taking a shape, flipping it over a line. The pre-image and image have opposite orientations, like I did here, like this one facing a different direction. But they're still the same shape and size. Again, it could be a point, triangle, quadrilateral, some image, some figure, I should say. Take 10, 15 seconds. Again, circle true or false. A reflection is a rigid motion. Reflection is a rigid motion. True or false? About cat. You said true? Yeah. Yeah. Sorry, it's true. Rigid motion means congruent. So essentially it means congruent. The pre-image and image are congruent. So if I just reflect something, over, it's still going to be the same size, same shape. It will be congruent. Now in this one, translation, hardly anything changes. In this one, like, the slopes of the lines actually change. But the lengths are still the same, the angle measures, perimeter, everything else is the same. Okay, I'll talk through these two methods. Again, just like the translation. You could plug in a point according to a rule, or you could do a graphical approach. So I'll show you both. Okay, they can ask you to reflect over the following: a horizontal or vertical line, or a diagonal line. As far as I know, the diagonal lines are only going to be these two: y equals x and y equals negative x. So, I mean, of course, there's other lines, you know, negative 2x plus 4, like different lines, it'll be like this, that don't go through the origin. And it doesn't seem like they're going to ask you to reflect over that, maybe, or maybe I should say I feel like those would be wrong choices if they said that as like a multiple choice. So I can't guarantee that, but if you're not sure, like you could graph this line on Desmos, get an idea of it, see if you can view it graphically. So I'm going to focus on any horizontal or vertical line, and then these two, y equals x and negative x. All right, so I will show you, first of all the formula ways to do it, and then when we get to the examples, I'll show you the graphical way. The first one in all of these is, it's a different way to say reflection, but I'm just going to focus on this way. X, Y, arrow, and then something there. Okay, so let's do an example. X-axis. Say I had the point 2, 3. And I want to reflect over the x-axis. Would you agree the point would be down here? What do you think that coordinate's going to be? For the entire point, the two coordinates.
No.
Well, it's 2, 3.
Oh.
So 2, right? Still right 2, right?
Yeah.
Right 2. Negative 3. Yes. Thank you. I just wanted to do that so that then you could see, yes, that's what it would be if we reflected with the x-axis. That rule, you see how the x doesn't change, but the y changes sign? Oh. So naturally, the rule is right here. The x stays the same, but the y is negative. Y-axis, just going to be the reverse here. Let me stick with 2, 3. If I reflect over the y-axis this time, I'll be over here. What point would that be this time?
-2, 3.
This time the x changes sign, but the y stays the same. So if you're a formula person and it says reflect over the y-axis, and you're reflecting and you have a triangle or something and you list your points, and these are the points of your triangle. If you're a formula person, just plug them in here. X is 1, y is 2. You plug in 1, you plug in 2, the new point will be negative 1, 2. If you're a graphical person, I'll show you in a minute how to do it. Okay, so that's x and y axis. Now they can also ask you any other horizontal or vertical line. And I'll cover one of those down below. There's no formula for it. Next, y equals x, y equals negative x. Now, y equals x is the equation. Y equals 1x plus 0. In other words, it's just the diagonal line that goes through the origin. It has a slope of 1. Okay? Now, this one, I think I'm just going to have to, let me tell you the rule and then we'll look at what happened. The rule is yx. Now, I like to think of it this way. We're reflecting over y equals x. Well, it literally says that y is actually x. So what they do is they replace y with x. But then x is also y, so they replace x with y. They're literally interchanging those because y is equal to x. So what this one does, it just interchanges. I'm going to choose the point 1, 4. If I choose that point, it's right there, my new reflected point would be interchanged for 1. And again, if you're a rule person, then you would just say, all right, 1, 4. I put x in there in 1, 4 in there is the y. Let's see. I'll tell you what to do if you're a graphical person, but we're going to do this one down here. So, And finally, y equals negative x. That's negative x plus 0. Negative 1x plus 0. Diagonal line go in this direction. I'll stick with the same point. If I do 1, 4. Oh, also, hey, on this one, lots of times I like to do this, like turn my paper or just turn my head to the side and I can see, yeah, it does look reflected. That's a good thing to do. Kind of match up your eye with your eyes with that line and make sure it does appear to be reflected. Okay, so this one, negative x. Well, it's the same as the last one, but each of the coordinates are now negative. So if I'm at 1, 4. 1 is my x, 4 is my y. Putting them in the formula, though, it's negative 4, negative 1. And if I look along this line, it does appear to be reflected. Okay, if you didn't like there's too many rules to remember, I'll show you graphic. I actually pretty much do graphically for all of them when I do these problems now. I think it's quicker. So any questions on those before we try the examples with it? Okay. So first one with reflections. Let's plot these 3 points. 2, 4, 6, 5, 3, 1. Triangle A, B, C. Draw the image, so this one is graph, draw the image of triangle ABC reflected over the x-axis. So I'll do 1 point with the formula, but guys, it's actually much easier to kind of do the counting one. The formula says it is x negative y. So if I'm a formula person, I take 1 point, x is 2, y is 4, and I put in 2 for x and 4 for y. I keep that negative there. So 2, negative 4. Now, on these horizontal vertical lines, I think this is a much easier way. It has to be the same distance away. So A and A prime have to be the same distance away from this line. So I just count. That was 4. Count down 4. And there's the point. C, I count down 1. Down 1. B is down 5. And I go down 5 again. A prime, yes. So, it has to be the same distance away from that line. I think that's a little bit easier, but again, whichever method you prefer is fine. Let's do the last 3. Let's go ahead and do this. I'm going to go ahead and graph. All of them start with the same points, the same triangle. And then we'll perform one reflection to each triangle. So I'm going to graph these 3. Actually, just because some of these graphs get a little cluttered, I'm just going to leave it as there's the 3 triangles. I'm not going to name them. I'm not going to label them. Okay, so I'll give you a second to write that down, but I'm going to go ahead and start on part A a little bit. So let's go ahead and we'll graph the final image for all 3 of these. Reflect over x equals negative 2. We didn't do one of those above. There is no rule for this. Who can tell me what that line looks like? Okay, someone's not sure. How about this? If you're taking the test and you have it's on the computer, what can you do to make sure you know what that line looks like? Put it in, well, you know what? Only the newest graphing calculators can do that. I think the TI-84s will not. But you can put it into Desmos, right? So if you're just completely not sure, put it in Desmos. X equals negative 2. and it'll give you a vertical line. So here's your reminder. Vertical lines are x equals a number. Horizontal lines are y equals a number. Vertical line of x equals -2. Alright, so there you go. Vertical line. Now there's no rule for these. I'm just going to do it graphically like I did on the last one. Each point, I just count to the line. So at point A here, I'm counting 1 to the right, and then 1 right again. So notice over here at B and C, I'm counting with the left now. Counting to the line. So at B, or wait, this is actually C. I count 1, 2, 3, 4, 5, 6 over left, and then 6 again. B, I count 2 left, and then 2 left again. And then looking at that, yeah, it does look like it's reflected. I line up my eyes. This is a good example too, that the line of reflection can go through the triangle, can go through the figure itself. So also if it said y equals -2, horizontal line. If you're not sure, put them in Desmos or your graphing calculator. Okay, the next one, x, y to yx. Now this one, it doesn't say in words y equals x, but we should recognize this rule is reflect over y equals x. That's right. Sure thing. All right, fine. Very well. So y equals x. If you're a formula person, remember that's the rule right there. -3 in for x, 4 in for y. So I plot 4, -3. I'm just interchanging the two, guys. So b prime will be 1, 0. Next one, interchange 2, 4. You know what would help too? I didn't draw in y equals x. So there you can see when I draw in y equals x. If you look at it along y equals x, it definitely is reflected. Now I want to show you one other thing about this. So if you're a graphical person, I actually think it's a little easier to do this. Well, this one's not interchange. It's kind of easy. But if you're a graphical person, let me do it that way. Oh, I didn't think of that one. There we go. Here's what you would do. So you take each of your points. So I was at, what was that, -3, 4. You count to the line, horizontally or vertically. I'll go down. So I count to the line. Then, if I want it over, right, it's going to be over here somewhere. I count then horizontally the same distance. So that was 7 down. So I go 7 over. Okay, it would have worked the same if I went right and down, because it would be a rectangle. Yeah. So I can do it again here. Down 1, right 1. There's my new point. What point is that? That's 4, 2. So here. So this one, I'll go up 2 and left 2. So you count to the line. They might not all be going the same direction, but it will work. So where was my final ones? Here, here, here. There we go. So graphically, it can work as well. Let me do the last one, see what questions we have. Last one, it's switching the x and y's, and it's negative. So this is y equals -x. If I draw on that line, it's diagonally through the origin, slope of -1. I'll do a little bit of each on this one. So say I'm at -3, 4, I'm doing that point. So if I'm doing this rule, I put -3 in here for x, so -3 is now +3. And I put in 4 here for y, and that's just -4. So -4, 1, 2, 3. So now watch this graphically though. If I did it graphically, I was here, I count 1 left and 1 down. That was it. This one, I count 1 left and 1 down. This one, I count 3, 4, 6 left and 6 down. anything I can clarify, answer about final couple examples there with reflections?